Hi class, we meet again in this video. So we are going to continue with your next chapter, which is the final chapter in this mechanical engineering class, which is internal combustion engine. Alright. So what does before we go into this internal combustion engine, I just want to recap a few things that we have learned previously. Right. As I said, the first three chapters in this class is about theoretical part, and the 4, 5, 6 is about the applied part. So in the applied part, our concern is about power. As a mechanical engineer, our concern is about power, right? So we have go through the first part, which is this vapor power cycle. So when the name is vapor power cycle, it's basically that working fluid that we are using is vapor. And then the second one, we have a gas power cycle. So the working fluid that we are using is actually your ideal gas. In this case, in this mechanical engineering class, we are going to only focus on your air, which is the ideal gas that used in your combustion. Okay. So in vapor power cycle, we have learned about this Rankine cycle, and it is applied in your steam power plant, which is these have already been taught in your chapter 4. And next we have gas power cycle, which we learn about Brayton cycle, and it's been applied in your gas turbine plant, which is we have already learned in chapter 5. And finally, this is the chapter that we are going to cover this week, which is your Otto cycle, diesel cycle, and dual cycle, which is applied in this engine vehicle. And this is what we are going to learn in the final chapter, which is chapter 6, right? So vapor power cycle, which is one of it is Rankine cycle that we use in steam power plant. It is actually an open system, and the type of working fluid we use is your vapor. And in order to solve this problem, we need to use your property table, which is in your textbook, that covers table E4, E5, and E6. And then next, we have this gas power cycle, which is Brayton cycle applied in your gas turbine plant, right? This is also an open system, and the working fluid that we use is gas type. Okay, so we are going to use that PV-MRT and this isentropic equation for the ideal gas. And finally, which is this week, we have this gas power cycle, consists of Otto, diesel, and dual, applied in your engine vehicle. This is actually the theoretical part that we learn is about closed system, and also a gas type working fluid, which is we are going to analyze about your ideal, right? So closed system is basically when we have recall back that in first chapter we learn about this piston, where you have compression and expansion. So the theoretical part will be applied in this final chapter, which is your engine vehicle, right? So I will explain it in the next video on how this this Otto, diesel, and dual cycle looks like, and then we are going to try on one example for you to solve. Thank you.